That skill presents Cartesian Trigonometry. Thus far we have learned that the 6 trigonometric functions, namely sine, cosine, tangent, cosecant, secant and cotangent, are defined only for angles inside a right angle triangle, which essentially means that this angle theta has to be less than 90 degrees, because after all the 3 angles in a triangle add up to only 180 and you already have a 90 over here. So theta is larger than 0 but less than 90 degrees. However, we can extend this idea to include all angles in a full circle, which means theta can be anything between 0 and 360 degrees. To be able to do that, let's have the x and the y axis, the xy coordinate plane. So this is x and this is y. Let's draw a circle that is centered on the origin on the coordinate plane. So this is the center of this circle, and let's say the radius of the circle is r. Therefore we have a r here, we have a negative r here. This is x on the negative side. Similarly, we have the y-intercept over here as r and a negative r on the other side. Let's also say there's a point P on this circle whose coordinates are x comma y. Let us join that point P with the origin, and let's go ahead and complete the right triangle. As you see over here, this is the 90 degrees, and let's name this point Q. The length of OQ obviously is the x coordinate of this point P, therefore this is x, and the length of PQ is the y coordinate of this point P, therefore this is y. Let us say this point P makes an angle theta with the positive x direction. Let's use some known facts from right triangle trigonometry. We know that sine theta is equal to the opposite over the hypotenuse. The radius of the circle is r. The length of the hypotenuse is nothing but the radius of the circle, so this is r. And x, y and r are related by the Pythagorean theorem, so that we have x square plus y square is equal to r square. Coming back to the sine function, we have sine theta is equal to this over this, so which is equal to y over r. Cosine theta is equal to this, the adjacent over the hypotenuse, so that is equal to x over r. And tangent theta is equal to y over x. We also know that the cosecant theta function, which is the reciprocal of sine function, is r over y. Just flip these over. Similarly, the secant theta function is equal to r over x, and the cotangent theta function is equal to x over y. Remember, the coordinate plane is divided into 4 quadrants: 1, 2, 3 and 4. I hope you know that. This is 4. In the first quadrant, if you look at any point in the first quadrant, x and y are both positive. So we have x as positive and y as positive in the first quadrant. If you look at any point on the second quadrant, x is negative but y is positive. Points in the third quadrant are such that x and y are both negative. And finally, points in the fourth quadrant are such that x is positive, so x is positive, but y over here is negative, so y is negative. And we can actually extend this idea to any angle in any of the quadrants. If you keep moving this point along the circle, that point P along the circle, theta increases from 0 all the way up to 90. It crosses 90, it comes down over here to 180 degrees, and then it crosses 180 degrees. You have a 270 degrees here, and by the time it completes the full circle, theta is actually equal to 360 degrees. So if we extend this idea, we can pretty much find the trigonometric ratio of any angle between 0 and 360 degrees. We don't have to restrict ourselves anymore between 0 and 90 degrees. Now if you look at these functions, you'll realize that in the first quadrant everything is a positive. Therefore we say all is a positive, all positive. This is my way of writing positive plus VE shortcut. So everything, all the trigonometric functions are positive if theta is an angle in the first quadrant, meaning it lies between 0 and 90 degrees. When you come to the second quadrant though, x is negative and y is positive, which means sine theta is positive, cosecant theta is positive, but cosine theta, secant theta, tangent theta and cotangent theta, they are all negatives because x is negative, and if you are dividing a positive with a negative or a negative with a positive, remember r is a positive number, so you get a negative. So in the second quadrant we just say that sine and its reciprocal, that is cosecant, only these two are positive, everything else is negative. Similarly, in the third quadrant, if theta were to be an angle in the third quadrant, meaning it's larger than 180 degrees, remember if you go all the way up to here, it's a 180 degrees. So we are referencing angles that are larger than 180 but less than 270, because by the time you come here and enter the fourth quadrant, this angle out here is 270. So for theta between, let me just write that down. So in the first quadrant, theta is between 0 and 90 degrees. In the second quadrant, theta is between 90 and 180 degrees. In the third quadrant, theta is between 180 degrees and 270 degrees, and finally in the fourth quadrant we have theta lying between 270 degrees and 360 degrees. Now coming back to this, in the third quadrant, when theta is between 180 and 270 degrees, x and y for any point in the third quadrant are both negative, which means only tangent and cotangent are positive. When you divide a negative with another negative, you get a positive. But because you have a r here, r here, r here and r here, that means either r is being divided by a negative number or r is dividing a negative number. Sine and cosecant and secant are all negatives. So we just say that tangent and its reciprocal cotangent are positive. And finally, in the same way, in the fourth quadrant, because x is positive and y is negative, we have cosine and its reciprocal, which is secant, as positive, and everything else is a negative. So for example, if you want to find sine 90 degrees, 90 degrees would take that point P right over here. We know that sine theta is y over r. Now the value of y is the same as r, so we have r over r, which is 1. So we say sine 90 degrees is equal to 1. Let's say we want to find out cosine 180 degrees. Cosine 180 degrees is equal to 180 degrees, like I said, is all the way up to here. So that point P comes and sits right over here. Cosine theta is x over r, so that's x over r, which is equal to, x is negative r, so we have negative r over r, which is equal to negative 1. In this way you can pretty much find the trigonometric functions of any angle between 0 and 360 degrees.